Hey guys, so before we get on to the main part of the video for today, I'm just going to very quickly go over the lesson starter that I asked you to do. So first question is to write down the formula for the following. So the first one is sodium oxide. Okay, remember the way to work out the formula is SVSDF. Okay, sorry for the light. If I make this brighter, does that help? Nope. Slightly. Okay, so symbol for sodium is Na. Symbol for oxygen is O. Valency, sodium's in group 1, so it's got a valency of 1. Oxygen's in group 6, so it's got a valency of 2. We can swap them over. We can't simplify it, so that just gives us 2 and 1, which gives us the formula Na2O. Okay. For question 2, let me just check. It is fluorine. So the symbol for fluorine is F. However, fluorine is one of your diatomics, so it has to be F2. Okay. Remember, elements on their own is just their symbol, unless it's diatomic, in which case it becomes the symbol with a 2 next to it. That should have said number 2. This is now number 3. Number 3 is for nitrogen trichloride. That's it. Nitrogen trichloride. Okay, so nitrogen, no prefix, just gets a 1. Trichloride, Cl3. Remember, for prefixes, you don't swap it. If it's got a prefix, that tells you the number. You don't need to do anything to it. Okay, number 4. Let me just double check. Magnesium sulfide. SVSDF, because we don't have any prefixes. Magnesium symbol is Mg. Sulfur symbol is S. Valency for magnesium is 2 because it's in group 2, and sulfur is also 2 because it's in group 6. We can swap them over, but it just ends up the same. We can divide these. We can simplify it down to 1 and 1. Therefore, the formula for magnesium sulfide is MgS. Okay. Cool. Let's go on and look at question 2, or the second part, which is to work out the gram formula mass. Okay, so NH3. I don't know how Mrs. Smith does it. I like doing it this way because it just looks really nice. So the mass of nitrogen, I've literally just got my data booklet here, 14, and there is 1 of them. Hydrogen has a mass of 1, and there is 3 of them. So that gives 14 plus 3 equals a mass of 17. Because it's gram formula mass, it's in grams. Okay. Second one is for C2H6. So this is for number 2. Okay, carbon, if you look up your data booklet, has a mass of 14, and there is 2 of them. Hydrogen has a mass of 1, and there is 6 of them. That gives 28 plus 6, which gives you a mass of 34 grams. Okay. So that 1 mole of that gives you 34 grams. Okay, 3. Hopefully it's another one that I can remember the numbers for. It is not, because I do not remember sodium. NaOH. Let me just do the ones I do know. So oxygen is 16. There is 1 of them. Hydrogen's 1, and there is 1 of them. Let me very quickly look up sodium. 23. Should have known that. No. 23. So there's 23 there, and there is 1 of them. Okay. That gives 23, that gives 16, that gives 1, that adds together to 40 grams. Okay, final one is NH4NO3. I do know all of these, that's exciting. So nitrogen has a mass of 14, there's 1 there. Hydrogen has a mass of 1, and there is 4 of them. Nitrogen again has a mass of 14, there's 1. 16 times 3. So that's 14, that is 4, that's another 14, that is 48. Can I do this in my head? 14 plus 14 is 28, 32, 80. Okay, that gives you 80 grams overall. Okay, hopefully that makes sense. Yeah, okay, so yeah, this will now cut to the main lesson for today. So go ahead and learn something new, and I shall see you guys later. Bye. Hey third year, and welcome to this video on your new content for today, which is balancing equations. Okay, so don't write down anything in your notes until it says at the top in your notes. Okay, the rest is just for your information to help you understand. So we already know that chemical equations tell us the chemical formula of all the reactants and products. Okay, so if we look at this example, we've got sodium oxide reacting with hydrochloric acid, and that gives you sodium chloride plus water. There is an issue with this though, and if you look, you'll see that there's two sodiums here and 1 sodium here. Atoms can't just randomly disappear and reappear. Okay, if we have 2 sodium atoms before the arrow, there must be 2 after. It must still be there. So this means that this equation is unbalanced. Okay. In order to fix this, we can then balance this equation. The importance of a balanced equation is it tells us the number of molecules that must react with each other and the number of molecules that are produced. Okay. So what I'm going to do is I have got a simulation based on different reactions. So let me take all of these away for just now. So if we look at this equation, nitrogen is going to react with hydrogen to give you NH3, nitrogen trihydride. Okay, also known as ammonia. That's why it says make ammonia. Okay, but we have the same issue that we saw a minute ago. We have the issue of there's 2 nitrogens here and 1 here, and there's 2 hydrogens here, but 3 hydrogens here. Again, you can't just have atoms appear and disappear. Okay, it's unbalanced. It's leaning more towards one side than the other, and this is leaning towards one more side than the other. Or in other words, there's 2 nitrogens and 1 here, there's 2 hydrogens and 3 here. It's not the same. What we can do is we can multiply the number of molecules that are in our equation. So the easiest thing to do first is to look at the nitrogens. So if there's 2 here and there's 1 here, well, what if we just had 2 NH3s? Suddenly we now do have, let me go back to the scales because they're better to visualize it. Okay, so if it's unbalanced here. If we have a second NH3, suddenly the nitrogens are balanced. Amazing. That's what we want. 2 nitrogens before and after the reaction, there's still 2 nitrogens. That makes our hydrogens really unbalanced though. What we can do is we can multiply the number of hydrogens that we started with. If we times that by 3, suddenly everything's balanced. Okay, we have 2 nitrogens before the reaction and 2 nitrogens after. We have 6 hydrogens before the reaction, 6 hydrogens after. What we've done is we've multiplied the molecules in order to make sure that we have the same number of atoms before and after. And this is what we're going to learn to do. Okay, let's look at another one, water. Let's give us a water molecule, which is going to break down into a hydrogen and oxygen molecule. Oh no. Hydrogens are balanced, great. We have 2 hydrogens before, 2 hydrogens afterwards, but oxygen's slightly tricky. We have 1 before and 2 after. Okay. If we end up with 2 oxygens, then we must have started with 2 oxygens. So let's add another water in. Suddenly, oxygens are now balanced. Okay, but by balancing the oxygens, we've now made hydrogens unbalanced again. But we've got 4 hydrogens here, 2 after. What if we just ended up with, 2 hydrogens? Okay, this is what balancing equations is. It's making sure that the numbers of atoms before the arrow and the number of atoms after the arrow add up. Okay, so let's go back to our notes. So in your notes, can you write this down? So a balanced equation is one in which there are the same number, let me just move my camera slightly, in which there are the same number of each type of atom on each side of the arrow. For example, this is the equation that was on the previous slide. So we've got 2 sodiums here. We now have 2 sodiums here because that 2 applies to the whole molecule. We have 2 NaCls. It's not 2 Na and 1 Cl, it's 2 Na and 2 Cl because the number in front applies to the whole molecule. We have 2 hydrogens here and 2 hydrogens here. Remember, if the numbers after it and down the bottom, it only applies to that. So there's only 2 hydrogens here and 1 oxygen, but there's 2 hydrogens and 2 chlorines here. Chlorines add up because we've got 2 chlorines in this one and 2 chlorines in this one. Okay. The numbers in front of the molecule tells us that 2 of the molecules are reacting and being produced. Okay. Can you pause for a second and write this down? And once you've written it down, unpause the video and we will move on. Okay. So this is how we're going to do it. Don't write this down. This isn't for your notes. We'll do a proper note in a minute. In order to balance the equation, we need to create an atom list. So we have this equation. We have Zn, zinc, reacting with HCl, which is hydrochloric acid. You don't need to know that, by the way. You'll learn that in the acids and bases topic. That reacts to give zinc chloride and hydrogen gas. Okay, so let's write an atom list. We have 1 zinc here, and we have 1 zinc on this side. Great, they're balanced. Might not be in a minute, but they are for now. Chlorines, we have 1 chlorine here, and we have 2 chlorines on this side. Hydrogens, we have 1 here and 2 here. Okay. What we can now do is start to multiply the molecules. And when we're multiplying molecules, the number always has to go in front. Don't put any numbers in the middle of molecules. That changes the molecule. We're not changing the molecule at all. All we're doing is changing the number of the molecules that we have. Okay. We must multiply full molecules to make the atoms match on either side. In this case, we can multiply the HCl by 2. If we multiply this by 2, suddenly the chlorines, we have 2 chlorines that matches, and we have 1 hydrogen that matches. Okay. How we write this down, and how I suggest you do it, is you write down the number and the equation, and then you go back and change your atom list. So we no longer have 1 chlorine, and we no longer have 1 hydrogen. We do have 2 chlorines, and we now do have 2 hydrogens, because that 2 applies to the whole molecule. These atom lists now match. That means that equation is balanced. Okay. Let's do a couple of examples for our notes, and then that is us done. Okay. So in your notes, can you write this sentence? In order to balance the equation, we need to create an atom list for each side and then multiply molecules until the atom list matches. Okay. And then this is just the example I gave you on the page before. Can you write this down? Yeah, that's what I thought. Okay, pause the video and can you write this down? And then we'll do a second example. And hopefully that will be us for this video. Okay, so example 2. We have this equation. Sodium oxide plus hydrochloric acid gives sodium chloride plus H2O. We have 4 different types of atoms now, so let's create our atom list. We have 2 sodiums on the left and 1 sodium on the right. We have 1 oxygen on the left, 1 oxygen on the right. 1 hydrogen on the left, 2 hydrogens on the right, because that 2, where's my cursor? That 2 applies to just the hydrogen. 1 chlorine on the left, 1 chlorine on the right. That is our atom list. Now we can start to multiply out the molecules in order to make our atom lists match. You can do it in any order, really. Sometimes there's some weird things you need to do in order to get it to balance. However, we can come to that later. So what I'm going to do is I'm going to put a 2 in front of the NaCl because I want to get my sodiums to match. Okay. I then cross off the sodium and the chlorine because that's the 2 atoms that are affected, and I have 2 of those, and I have 2 of those. Great, my sodiums are balanced, but my hydrogens and chlorines are still not. So what I can do is I can put a 2 in front of there. That balances out the hydrogens and chlorines to 2 and 2. That is a fully balanced equation because we have 2 sodiums here, 2 sodiums here, because that 2 applies to the full molecule. 1 oxygen here, 1 oxygen here. 2 hydrogens here, 2 hydrogens here, 2 chlorines, 2 chlorines. Perfect. Okay. Can you pause the video again and write this down? And then that is us done for the notes taking. Okay, so what I'm going to do is I am going to go back to the simulation for a second. Can you not? Thank you. Okay, so let's play the game for a minute, okay? Feel free at any point to come and try out the challenges. I'm just going to do level 1, the first couple, just to see how we're getting, just to check that we're getting on okay. Okay, so carbons, we have 1 here and 1 here, that's fine. Hydrogens, we have 2 here and 2 here, that's 4 altogether. And I've got 3 here and 1 here, that's 4 altogether. Oxygens, I've got 1 and 1. I don't actually need to do anything to this. This is already balanced. Okay. Let's go for nitrogens. Let's just put 1 of each on either side. Okay. I have 1 nitrogen here and 1 nitrogen here. That works. This is a trickier one. I've got 2 oxygens here, but I've got 3 oxygens here. What I can do is I can make this side a multiple of 2. That's going to make it easier. So if I put 2 NOs here, that gives me 4 oxygens. That makes it much easier to make that 4 as well. And now I also have 2 nitrogens. Ding. Let's do one more. I've got a molecule of C2H2, and I'm going to add a molecule of H2 to it. I have C2H6. Okay, I have 2 carbons here, 2 carbons here. Perfect. I've got 4 carbons here and 6 carbons here. I need to add 2 hydrogens on somehow here. That's as simple as just adding another hydrogen molecule on. Thing. Okay. So I'm not going to spend a lot more time going through that. Let me just go back to the balancing equations, just to put it up so we can see. Right, so feel free to go have a break now. Okay, that was a fair amount of writing. Hopefully this makes sense. Lesson 2, task 1 is to do some practice questions. So do the 4 practice balancing equations and check them. And then if you finish that, you can try question 2 of the worksheet, which is to start with a word equation, turn that into a chemical equation. Remember all your rules for creating formula. And then balance the equation once you've got a chemical equation and balance it. Okay? Remember, if you need any help, please ask. Please do not hesitate to ask for help at any point. Okay? This is a tricky concept and it takes a while for it to sink in. So I would fully expect people to be asking loads of questions. Okay? So please ask away. If you need anything, let us know. Let any of us know. And I shall see you all later. Thank you, third year.